Okay, so we talked about addition of the vectors, right? Let's see if we can do something similar with the forces. Forces are vectors, so it's easy to do them. So if I have a force of 5 Newton applied on something and a 10 Newton force applied in another direction, if I want to add them together, all I have to do is write each of these two forces along x and y direction and add them together. So along x direction, the component of f would be f cosine 45, so that's cosine 45 is 1 over root 2, so we get that. And y component of this would be 5 over root 2, so we get that right over here. And then this component, 10 Newton, is entirely along j hat, so we have 10, well, this is wrong, this should be 10 j hat. So let me make that correction. So this should not be 10 I hat, this should be 10 j hat, right? So this is the part that represents this force of 5 Newton, and this is the part that represents this force of 10 Newton. So how do you add them together? We have I hat component over here, and that will be itself, and then we have the j hat component, so we'll add these two numbers, and we'll get the total force, right? Okay, this is an example from your textbook. This is example 4.1. This is called an I-bolt, and this I-bolt has, you can see, 3 cables. There could be steel cables, and they are basically being pulled, okay? So there is this force of tension in the cable, and the 3 forces that are acting on this I-bolt are 800 pound that way, 350 pound that way, and 150 pound in that way, right? Now what we want to do is we want to add these 3 forces. So how do we add forces? Forces are vector. If we can write each of those 3 forces in terms of I hat and j hat unit vectors and some magnitude, we can add them together. So we need to pick a reference frame. So let's say this is the reference frame we are picking, right? So x-axis is pointing towards the right, y-axis pointing up, and I hat and j hat are the unit vectors. So when somebody says, please add these forces, and you're going to do it using Cartesian representation, you need to draw the coordinate frame. This is the most important thing. If you don't draw this coordinate frame, then we don't know which way your I hat are pointing, which way your j hat are pointing, right? Okay, so how do we add them? Let's first do the force F1. Force F1 is 800 pound. It's making an angle of 45 degree, right, from y-axis, which means this is also 45. So if I were to resolve F1, I'll get 800 times cosine 45 and 800 times sine 45 along x and y direction, and that's this number, right? 350, this is 20, so that's cosine 20 along y direction and minus sine 20 towards negative x direction, so we get that, right? Now, some of you may be in the habit of writing a vector by measuring the angle it makes from the positive x-axis, okay? And that's also okay. So if you measure your angles from the positive x-axis, then you don't have to worry about seeing which way they are really pointing, okay? All you have to do is, if this length is, let's say, f, then all you have to do is say f cosine theta I hat plus f sine theta j hat, and because theta is more than 90 degree, the cosine and sine will take care of the sines. So you won't have to worry about the sine. The other way is you do what we are doing over here. You look at the actual angle it is making from x and y axis and then resolve it along those directions. Finally, F3 is entirely along negative x direction, so that's minus I hat, and the length is 150. So now all you have to do is collect all the I hat terms and collect all the j hat terms, and you get your final answer, which would be something fx plus I hat plus fy j hat. To get the magnitude, you square them, add them together, do the square root. To get the angle, you do this, but of course, be careful about this. Why? Because you need to see where this vector is, which quadrant this vector is in. If it is in the first quadrant, then it's not a problem. You can just divide them. If it is not in the first quadrant, then you will need to see where it is.